devlog 3, an exploration of using stac-geoparquet with a stack catalog from itslive. Itslive is a pretty cool JPL project to publish glacier surface velocities all over the world. They have a pretty large catalog of data that they use to generate these velocities, and I'm going to show how we can use stac-geoparquet to make that catalog a little bit easier to use. So they have a pgstack database that with all the stack in it. They also have a backup in S3 of a bunch of nd.json files, and you can see that the nd.jsons just contain a bunch of stack items. There's a lot of stuff. I think it ends up being like 26 gigabytes in all, and so I'm just going to walk through a little bit of a notebook that I wrote, and then do some live exploration of how to turn this like 26 gigabytes of nd.json into stac-geoparquet, and then how you can use that stac-geoparquet to do queries and searches and things like that. So I'm going to just quickly show a little bit of the notebook that I wrote about this. So this is the S3 Explorer for these nd.json files. I'm using obstore here to go check out and see how many files there are and how big they are. This is where I got that number. It's actually 28.7 gigabytes worth of nd.json. So nd.json is pretty bloated. It takes up a lot of space, and so stac-geoparquet can just be really useful as a like storage format. And so I wrote a quick script here that basically takes all those nd.json files and writes them down into stac-geoparquet. So if we look in these folders, they're partitioned by space. In this case, you can see there's a bunch of parquet files in there. And so if I go in here and then use the GPQ, which is the geoparquet utility from Planet, to describe what's going on, I can see, hey, look, that 2025 parquet that's in this folder, it's a geoparquet file, and it's actually stac-geoparquet. So you can see that some of the attributes that are down, usually in properties for stack, have been brought up to the top level. There's a geometry here and things like that. That's pretty handy. You can see, though, that there's only, in this case, 900 items in this parquet file. And so that's not ideal partitioning. Parquet kind of works well when the partitions are a little bit larger. The recommendation in DuckDB is to be about 100 megabytes. And so in addition to just pulling down and converting those nd.jsons into parquet files, I actually used DuckDB to partition them. And the incantation is a bit gnarly. You can see it's listed here. But basically, I can read in all those parquet files that I initially wrote out, and then select the year from them, and then actually partition them out by year to a new location. And so I can show what that looks like in my Finder. So this is the original data just converted to GeoParquet. And then this is the same data, but reorganized into partitions. And you can see that some of these are still pretty small, but the year partitions are a little bit larger. And this can be pretty handy. For instance, it allows you to do really quick drilling down into by year. So if I'm only looking for data from 2024, if you do that select, DuckDB will only go and touch the files inside that 2024 folder in here. So that's pretty handy. A neat feature of RustStack is that we can actually use Stack API queries against that same partition data set. So in this case, you can see I've made an href just out of the folder and then the star parquet notation. And I can actually search, okay, let's just find all of the stack items that are perfect valid pixels. Every single one of those pixels. You can see there's almost 40,000 of them. And I just searched through, and this took a couple of seconds at most. And so I was able to search through all of these, what was it, almost 10 million stack items? Yeah. So almost 10 million stack items, and took a couple of seconds, but I was able to use DuckDB with a Stack API query to do that. So that's pretty handy. A kind of added feature is that you can actually search directly to Arrow. And so if you're trying to do work in geodata frames, this shows how you might use a Stack API query to go to a geodata frame and do some work from there. So a little bit of just a show and tell demo. This notebook is public and live, and it's part of our explorations into how we might start using GeoParquet more, stac-geoparquet more for these larger data sets. Thanks a lot.